The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. My name is Bill Brayton, ATRA Senior Research Technician, and this is a webinar on the DPS6 internal operation. Thank you for taking the time out of your busy day to attend and get some education going on here. Today's seminar is brought to you by Seal Aftermarket Products. Seal Aftermarket Products. There we go. Your source for engineered solutions.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, so as we go along, if you have any questions or comments, either before, or during, or after, please send emails to webinars@atra.com. Or if you have any questions regarding the material that we're covering, please feel free to text them in the question box and we'll get those questions answered straight away. Okay, we have a full summer of education coming up. We have one more in July, 2 in August, 3 in September. We're going to round out the year in October with the 6R140 problems and fixes. So be sure to mark those dates on your calendar. Another date to mark on your calendar, October 29th through November 1st, Expo 2015. We're having it again at the Rio Hotel and Casino in Las Vegas. Had it there last year. It's a great facility. We're moving into a bigger room this year, so mark your calendars to be there. Also, on the Saturday technical seminars, we are giving away to one lucky attendee that goes to the Saturday seminar a free expo package. That includes a complete conference registration. That's the tech material, the management material, the showroom floor, the luncheon, and 4 nights. We're going to pick up your hotel. Just got to get yourself to Vegas, and we'll take care of the rest when it comes to the convention. But you have to be at that Saturday seminar in your area to win that free package. Okay. We get into the DPS internal operation, but first we want to cover the applications here, the 11 through 15 Fiesta, the 12 through 15 Focus, the 12 through 14 EcoSport, which is a overseas model, the 2012 through 2014 B-Max. It says global next to the B-Max, but I have seen those around town. And then there's the 14 C-Max, which is also an overseas model. Okay, so some of the noise characteristics, or some of the common characteristics, are sounds and vibrations that the customer might not be expecting, such as double clicking metal sounds while driving on very smooth surfaces. During the 1-2, or maybe it's the 3-2-1 coast down, these sounds are when the gears are simply changing gears. And these are very noticeable. Smooth road, windows down, it's quiet. You can hear the thing shifting because it's an electronically controlled stick shift is what it is. So you might even get a coast down whine. It's like gear noise. That's totally normal. Clicking sound after the engine's turned off. The way this unit works is when you put it into park and you shut the key off, the computer, the TCM, shifts the transmission in neutral. It does not need to stay in gear because it's got a park pawl and a park gear, which you'll see also later on in the show. Slight grinding noise might be heard at 2 miles an hour, maybe a trailer hitching. Normal bearing gear rotation doesn't affect the durability of transmissions. Let's see, reverse gear whine. See, the biggest thing with this unit is that the floor salesmen at the dealerships are selling people automatic transmissions, and people are expecting traditional automatic transmission behavior, and that's simply not the case. It's a electronically controlled stick shift where the clutch is also controlled by the TCM. The clutch, the green clutch or a brand new clutch might, it has a break-in period where the TCM learns the clutch, and you might hear things like a rattle noise on light throttle upshifts might go away as the break-in takes place. So that's all normal. Takeoff, shutter, launch when it's just getting broken in, harsh shift feel when it's cold, all normal behaviors for this stick shift transmission. And so I even had a guy call me last week. He said, this is here from the dealership and the lady wants a second opinion, and he says, I'm not really sure how this thing's supposed to work. I mean, when I put it in drive, it feels like a torque converter shutter on the takeoff. And I says, well, that's because this is how it works. It's a dual clutch dry disc transmission, and those types of shift feels are pretty normal. So let's take a look. Let's get into taking this thing apart. The front cover comes off. It's not a bearing retainer as in the traditional sense of front covers. It merely is a front cover that comes over the front seal. The front seal has been taken out in this illustration. These units, the Ford Focuses and Fiestas, I'm not sure about the B-Max, have had 100% failure of this seal and the inner seal, which seals the hollow shaft to the input shaft, to the solid input shaft. So pretty much every one of these that rolled off the assembly line had defective seals here and caused the launch shutter. Every one of them had to go back to the dealer to get these seals changed. When I was writing this webinar, I was over at the dealership getting information, and they were doing 2, sometimes 3 of these things a day. So if you see one of these come in that has a brown seal in both areas, those are, in fact, the updated seals. Well, let's take the snap ring off, turn this thing over on the bench, take the TCM off. It's simple. It's just 3 bolts, comes right off. We can see what we're looking at here. This is the TCM. These are the 2 shift control motors. These engage into the clock gears. You can see through the windows right here. There's a better picture coming up that we'll see these gears and how they're laid out inside the unit. This was obviously out of a wrecked unit. Big hole in the case right there. Okay, we also need to take off the park lever position sensor. This indicates into a slot on the park lever rod, which is right inside here. This park lever arm unbolts from the transmission. It's the only piece of external linkage on this unit. This is attached to the shifter via a cable. All it's for is to move the park pawl in and out of the park gear. Okay, first we need to remove the 6 10mm retaining bolts. These are screwed into plates holding the bearings, the internal, the output shaft bearings to the case, and the 23 case bolts. Turn it over, bell housing up. All the guts are going to stay in the main housing for right now. We've got several different places to get a good pry on this thing so we don't have to go into the gasket area. It pries up and off. Fairly simple with those slots. But what you need to do, what's an important disassembly tip here, is to use a deep socket and tap on the hollow input shaft instead of tapping on the solid input shaft, because it's this outer hollow shaft that is pressed into the front bearing. And tap on that lightly and the case comes right up and off of the gear train. Here's a look at the components that make this dual clutch unit so unique. We've got the clock gears over here. Now we've got 2 output shafts engaged into the differential, and we have 2 input shafts, the hollow and the solid input shafts. Excuse me. So here's the slot where the PLP, park lever position sensor, rides. Our park actuator lever. We're going to see a better picture here of this in just a second. So we're going to, here's that park pawl and the park lever. The park pawl is engaged to the lever via a pin in a slot. So there's no spring assembly on the pawl itself. The anti-ratchet spring, I guess you'd say, is over here on the lever. Here's a look at the clock gears, 2 on each side. You can take the pins out and toss these into the basket. They are interchangeable, same diameter, same tooth count on both of these gears. You can swap one side to the other, doesn't matter. These gears provide a 61.44:1 ratio, which means that the motor we saw in the TCM spins 61 times for 1 revolution of the drum. This provides a crazy amount of torque, up to 330 foot-pounds of torque, to move the shift forks swiftly and smoothly. So the shifts happen very quickly without much effort on the motors, the wireless brushless motors. So we take these pins out and set the shafts aside. We'll go ahead and take the park pawl and the selector shaft, the side. Now, at this point, the Ford's way is to use this special holding fixture 307680. Here's the bottom view of the fixture. Here's the top view of the fixture holding all the components with the case removed. And then there's some shaft support tools that they want you to use. Well, I didn't want to spend the money, and neither did Atra, so we figured out a way to get this all done without all the holding fixture tools necessary. Here we've got the picture where the clock gears are out, the pawl and the shaft are out, and the differential's out. So the drums stay, these are called shift drums. These stay in because they're indexed into tabs attached to the shifting mechanisms. So what we're going to do is we're going to take the front bearing out of the case. So take the number E8 star bolts out of the retainer, go around the other side and use an appropriate driver and tap the front bearing out of the bell housing. So now we've got the bell bearing out of the bell housing. We're going to put the bell housing back on to the main case. And when we do that, it just settles right on there because there's nothing to tap back together. The front bearings out of there, so no problem. And the case has come together. We take a couple of bolts and put the case house together, flip it over on the bench, and remove the 2 finger tight bolts, and that's what we're left with. All the parts hang out in the case, and now our bell housing is a holding fixture. Here's the shift mechanism identification. What's kind of interesting here is the way they're arranged in relationship to the gear selector drums. This is the 2nd and 6th shift fork assembly. The 2nd and 6th gear is over here. You can see the shift fork engages into the slot, which the tab fits into the drum. So the gear drum, the gear selector drum on the left works the 2-6 over here on the right, and the selector drum on the right works the 3rd gear selector. The gear drum selector, gear selector drum is fitted to the linkage here, which is slotted into the shift fork over here on the left. So the fork is on the left, the drum is on the right. And this is a real good look at the difference between the shift drums. They are not interchangeable whatsoever. You can't put these in the wrong place no matter how hard you try. I know because I did. Anyways, so here we go. We saw how it is apart right here. Well, we've got it at this stage of apartness. We're going to take a minute to see how this unit works. So here we have it. This is what the trans would look like sitting in 1st gear at a stop. The shifter forks up. It's in the 1st gear. We're waiting for the red light to turn green. Got our foot on the brake, ready to go, and off we go. Take our foot off the brake, give it the gas. Now, when that happens, the transmission, the TCM, shifts the shift fork into the 2nd gear position. Now, some of you old school guys, this might look a little strange because anytime on those old sticks used to have a shaft that was in 2 gears at once, it meant that the unit was locked up solid and the unit wasn't going to turn, the shafts weren't going to turn. But because the first gear is driven by clutch number 1, and second gear is driven by clutch number 2, and clutch number 2 is disengaged, we can have these sliders in the first gear and second position at the same time. So as we take off from a signal, we go up and up. The TCM stages the transmission to be in second gear. When it wants the 1-2 shift to happen, it simply transfers the drive from clutch 1 to clutch 2. The shift is made. That's all that happens. Technically, you shouldn't feel anything at all. If you ever watched a Formula One race on a Sunday afternoon, you'll see the Formula One cars, the in-car camera, accelerate from nothing to a crazy amount of speed, and you hear them shift up through the gears, and sometimes you'll barely even see their fingers move when they're pressing the buttons, and you can hear the gear changes. You can't hear the gear changes, but you can hear the engine speeds change as it goes through the shift sequence, but you don't see the car jerk, or there really isn't much of a shift feel that you would think be associated with the clutches going in and out. Well, and the reason why is because they can time the off-coming and ongoing clutch so that there is no shift feel. And I drove a couple of these over at the Ford dealership when I was doing the research for these webinars, and the engineers at Ford built in a bit of overlap so that the customer feels the gear shift change, kind of like they did on some of the later model CVTs, where they built gear shift changes into it because the customer wants that feedback from the transmission. It's no different here on this on the DPS6. So now we've made the second gear shift, and now we've made the second gear shift. The computer has moved the shift fork out of first gear, and because we're driving off of the clutch number 2 in second gear, clutch 1 disengages and now moves the shift fork into third gear, so that now we're actually in second and third at the same time. So when the shift comes time to get ready to happen, once again, it goes changes the drive from clutch 2 to clutch 1, and you have your gear change. And this is the way the shifts take place all the way up through the sequence, and quite frankly, all the way down through the sequence, that it can pre-stage the transmission into the next requested gear prior to the shift from actually happening. And that's why the shifts are able to happen seamlessly, and actually it becomes a great gas mileage thing. Okay, so we've seen how it works. I'm not going to go through 4 to 5, 5 to 6, and so on and so forth. You get the idea of this. This is how the shifts occur. So now that we know how it works, let's finish taking it apart. The thing to note over here is that these two shift shafts are shorter. If we get these mixed up, you can see these two larger shafts, larger diameter shafts, are of equal distance sticking out of the shafts. This shorter shaft or this longer shaft in the wrong place will obviously be sitting too low and be sitting too high over here. And here you could see they're nice and even when they're installed into the correct place. So we take the shafts out, and the input shaft's going to fall over to the side as we see here. No problem, bearing's not there. Remember, the bearing's not there to support this, so now it's pretty much just being supported by the shift forks. So one at a time, we pull the shift forks out and set them aside. Very simply done. Now we're left with the 2-6 shift mechanism still in place because it's being held together, held in place by the 2 shift drums. Well, what happens now is we pull the shift drums out. Like I said, tall one on the right, short one on the left. They cannot be interchanged at any time. The slots and the tabs from the forks will never line up. That's pretty evident. No marking necessary. Then we pull the shift fork, the 2-6 shift fork away and pull out the input shaft. It's just that simple. The key in taking this all apart was removing the bearing. That's what allowed the bell housing to become the holding fixture. So now we're ready to lift the output shafts up and out of the case. The thing that we have to watch for now is the plastic tubes. We do not want to break those plastic tubes. Those parts are not available right now. The individual parts for the case and the shafts, that is the Synchros, the Synchro hubs, the sliders, the bearings. I spoke with an engineer in Detroit working on this project, and he says they're in the midst of cataloging and putting together the aftermarket parts, or the parts available from the dealer, I should say, to the aftermarket within the next 6 to 12 months. So unfortunately, if you broke this tube, you'd have to end up buying the whole case. So as well as if your synchronizers are flat or your sliders are worn out or gears are worn out, you must buy the whole shaft at this time. But that's really only temporary. Their bearings are available in the aftermarket. Just use the bearing numbers, the individual bearing numbers, and you will be able to get replacement bearings for those. Okay, so the next couple of slides are not in your handout. They're not in your handout. I put them in fresh yesterday before the webinar. And what you need to do is when they come up, there's 3 in a row here, just hit the camera icon on your screen, and that will put a JPEG on your desktop that you can add to your seminar file. So what I did was I pressed the gears apart, pressed the bearings off the shaft, pulled the gears apart, wanted to take a look at the composition of the synchro rings. And quite frankly, to my surprise, this is what I found was a clutch material bonded to the steel ring. You can see the green adhesive or glue that they use to bond this friction material to the ring itself. Now, that was pretty amazing. We've all done a lot of stick shifts, and this is the first time I've seen a fiber media type of, looks like and feels like a converter clutch disc type of material. It's a pretty hard material. There's three sets of gears that have that style, and there's 3 sets of gears that have the detachable brass ring. The brass ring indexes into the gear, and the steel synchro rides on the brass. This transmission is fairly new, so this brass is pretty aggressive right there. This transmission, okay, we think about clutch material, we think about what kind of fluid this is going to have in it. This particular transmission, a guy asked me that question yesterday. I had to research it, and I found a part number from Ford, but it's in the red bottle from the Ford dealership. It's simply called dual clutch transmission fluid, and it smells like gear oil, if I could describe it, and It's clear like motor oil or gear oil, but it's about a 50 weight type of oil. It's just a little bit heavier than, not as thick as 90 weight, but not as light as transmission fluid. Definitely not pink in color. It's a gear oil color and smell. It actually smells more like hydraulic fluid than gear oil, but it is about the consistency of, I would say, heavy motor oil, but it's dual clutch transmission fluid. So make sure you always, when you're working on this, use the factory fill. Okay, I wanted to take a look at the synchronizer assembly, the hub and the slider, and it's put together with the spring and ball and these puck assemblies right here. I recommend not taking these apart unless this thing, and if this slider is, these teeth are all rounded out, I would be inclined to buy the whole hub assembly and slider put together. I mean, it's possible to put these things back together. I mean, with enough time, you can do it. It's just problematic. These white inserts are self-contained. The ball and the spring are all molded into the inserts here and here. But these, however, are going to be held together with a fair amount of grease, assembly grease, to keep these balls from bouncing all over the bench and to keep these tabs seated down on these shoulders. And so what you end up doing is having that all greased together and the slider getting pushed back down over that all in one motion, and it's just not something you want to do. So I don't recommend that. The other thing I did over here, it's a little difficult to see, but I took this over to the grinder and hit it a couple of times. I like to do this when I pull these hub and slider assemblies off, so that before I ever let them go, I walk them over to the grinder and I just hit it a couple of times. And this way I know that when it goes back on the shelf, when it goes back on the shaft, the marks always face me. And you know, this particular has 2 marks on it. If it faces 3rd gear, I might put 3 or 5th or 5, what have you. So just another assembly tip right there. Okay, so I got my new bearings on, I got my new Synchros in, I got my hub back together and all pressed together on the shaft, looking real nice and clean. Now it's time to put the thing back together. Well, we saw earlier those shaft supports. This is what those shaft supports do. But to hold the input shaft here mated into the output shaft, really simple. If you don't have any in your shop, you run down to the hardware store, pick up a roll of masking tape, take a couple of wraps on the masking tape. Doesn't take a whole lot of pressure to hold these things together. You're good to go. Now we're ready. This unit is ready to have the shift forks installed. Okay, on the left we've got the shift shafts installed. You can see they're here at the correct height. Our clock gears are installed into the bell housing. Tall one over on the right, short one on the left. All the forks are engaged. Got our shafts and our clock gears. Last thing we want to do is to put a couple of guide studs in the hold down plate. This is going to make for an easy alignment when the case goes back down onto the gear train. These plates only fit one way, and it's extremely difficult to get these things lined up without the guide studs in it. I tried. It takes a long time. Do yourself a favor, find a couple of bolts, make some guide studs. It's going to make your job a whole lot simpler. Okay, so now that we've got the case on, it's all a matter of flipping it back over on its side and reversing the disassembly procedure, which means installing the installing the differential, the park pawl and rod, and the park selector shaft. And then you're taking the bell housing back off the case, putting in the bearing retainer and the front bearing. Now we're ready to put the case back on the whole transmission assembly. That's when the sealer comes in, because that's our final time of putting it together. And that's as easy as it goes. Put the TCM back on. Now we're ready to go back in the car and go through all the learn procedures and whatnot. All right, well, that's the internal operation of the DPS6. Today's presentation was sponsored by Seal Aftermarket Products. And I would like to hear any questions that you might have at this time. Also a bunch of other sponsors, WIT, Gears, Toledo Transkit, Bold Electronics. Okay. Let's see. We don't have any questions today. I'd like to thank all the guys on the West Coast in the Pacific Standard Time for joining us today. My name is Bill Brayton, and enjoy the rest of your day. Goodbye.